analog and digital pins. We'll come to this a little bit later. And you also have to power up the board, right? You can't just connect them and expect it to work. You need to power it up. And to connect to the power supply, we have uh, ports on the board to connect to a power. Finally, we have communication interfaces through which you can communicate between boards, or you can have connect to Wi-Fi, Bluetooth. All of these come under communication interfaces. So this is the basic anatomy of a development board. In electronics, you will come across the terms microprocessor and microcontroller pretty often. Now, there's a very basic difference between these two. A microcontroller, it consists only of the CPU. It's only the brain. On the other hand, a microprocessor consists of the CPU, memory, as well as the input and output devices. It is an example of a microprocessor is Raspberry Pi. It is also called a single board computer. You can do all functions of a computer on the microprocessor because it contains all the components you need. A microcontroller is usually used in embedded systems, while a microprocessor is used in computer processing. These are some development boards that are microcontrollers, while Raspberry Pi is a microprocessor. So that's the basic features of a development board. Do you guys have any doubts? If you have any doubts, feel free to put it in the chat box, or you can unmute and ask now. Cool. Moving on. There are various development boards that are used in the industry right now. Uh, all these development boards, they have different features and different functionalities. Some are more suited to a particular application, and for different applications, you will require a different board. So these are some of the popular boards that are available. You have Arduino, which is used for basic applications, Raspberry Pi and Jetson Nano, which are much more powerful and used in the industry for more complicated applications. And you have ESP32 and ESP8266. Now we'll look at each one of these in detail and how you go about choosing which one you would require in your project.
Either.
Yeah,
Karan has asked you to explain the pins topic again.
pins. Okay. So in this picture, you can see that there are pins, right? So your microcontroller is the brain of your process. So it does all the process. But we saw earlier that we need input devices and output devices. So to connect these input devices and output devices, we use pins. They're basically connectors to connect between the devices and our development board. Is that clear? You can put thumbs up if it's clear for you. Okay, cool. Um, yeah, so let's look at the different features that these development boards have to offer. So the main features that you consider while choosing which development board you want to use are speed, memory, programming language, connectivity, and based on these, we have various uses. Speed is also the processing capability of your board. So if you have an application that requires a very high processing power, and then you would go for one of the higher end boards such as Raspberry Pi and Jetson Nano. But for simple home applications where you want to light a bulb or um, have a small burglar alarm, then you can go for some of the simpler development boards like Arduino and ESP. The development boards also come up with some built-in memory. They're in the increasing order of memory, as you can see. Arduino has the lowest, while Raspberry Pi and Jetson Nano have a pretty high memory. So they can be used to store data while you would have to attach a peripheral device and connect it to a USB maybe to store more data. The programming language for each board is also different, and depending on what you want to code, say you want to run an ML program, then you would prefer having a Python, prefer writing your code in Python, in which case you'd be using a Jetson Nano. But uh, while Arduino ESP32, they are compatible with C, C++. Raspberry Pi supports a lot of languages. It is a single board computer and you can use it for developing and prototyping code. So it is compatible with a lot of languages. Next, we come to connectivity. So you might want to have devices that require you to carry them around, in which case you will need it to connect wirelessly. Arduino, most boards in Arduino do not have wireless support, and Jetson Nano also requires Ethernet, while ESP32A, ESP8266, and Raspberry Pi, they support wireless connection. They can be connected through Wi-Fi or Bluetooth in these two cases. Bec- because they support wireless connectivity, you can use them in devices, in mobile devices. So in ESP32 is very commonly used in wearable electronics. So when you have a wearable electronic like a watch or so, you cannot afford to carry around it all the time, carry around a lot of electronics all the time. So uh, wireless connectivity comes in hand for that. And as you can see, these are the uses. Jetson Nano is used in AI implementation. It's capable of running AI workloads and used in image segmentation and classification. ESP8266 is commonly used in security and medical devices. Arduino is what we'll be seeing now, and it's a very useful and a very good starting point for you to learn electronics. It's a simple development board that can um, help in making very simple projects. Simple. So that's what we'll be focusing on now. I think someone's unmuted. Can you mute?
Yeah, Nikita, you're muted.
Yeah, okay. Thanks.
Yeah.
Does anyone have any doubts on the features? You can do all the stuff that you can do with an Arduino and Raspberry Pi, but it's just a waste of processing power. And they're also, because they have a high processing power, high memory, they're also more expensive. So it's more efficient to use an Arduino. No, I don't think the processor in your mobile is a Raspberry Pi. That would be a different microprocessor that the company would develop on their own. Power supplies, okay. So I will be coming to that later. You can power it even using your laptop. One of the common ways that we do power our Arduino is we upload our code. When we're uploading our code, we connect it to the USB port and the Arduino gets powered up. Okay, so an Arduino supports a 5-volt power. You can look up the specifications for whichever board you're interested in. I think I've answered all the questions. So let's move on to Arduino. Like I said, it's a very good place to start, and that's why we're starting with Arduino. So the first step in creating your own circuit with an Arduino is making the connections. Like I said before, we have pins on Arduino to make our connections. GPIO stands for General Purpose Input Output, and they are separated into digital pins and analog pins. We'll come to that in a while. And we also have power pins. These are used to power your devices as well as they can also be used to power the board as well. So we have the we in these three are used to power, and this is your ground pin. Okay. So I told you about digital pins and analog pins, right? So what these pins, they cater to different kinds of signals. So you have analog signals and digital signals. Analog signals is what you see all around you. It is a continuous valued signal. That is, it is not in steps. So if you take temperature, for instance, you can have 25 degrees Celsius, 28 degrees Celsius. You can also have 25.6 degrees Celsius. So it is not restricted to any range, or it's not restricted to a particular step value, say. On the other hand, a digital signal is either high or low. It is 0 or 1, like as in on or off. You can see here below that analog value takes all values within the range, whereas a digital pin takes only the maximum value and the minimum value. You can, what is the use of these digital signals? So in a microcontroller, all the processing and logic functions occur in digital values. You may have come across, say, and or logic functions, right? You can only apply those functions to zeros and ones. You cannot apply them to, say, zero point 0.5 and zero point 0.7. That doesn't make sense, right? So that is where we use digital signals. So within electronics, digital signals, all outputs that we get are digital. And every process, once we get the input, it's converted into digital, and that's how all processing occurs. Now the different kinds of pins are digital pins and analog pins. So the digital pins offer only two voltage levels. They can be either set to low or high. They only read low signals or high signals when they are input pins, and output pins can only send out either 0 volt or 5 volt. But analog pins, now they are only input pins. So when you have a sensor and you want to read the value of the sensor, it is not restricted to 0 or 5 volts. Say you have an ultrasonic sensor and you're measuring distance. It is not going to be 0 or 5. It's not going to be minimum and maximum. There will be values within minimum and maximum. So all those values can be read by the analog pins. Is that clear? You guys can put thumbs up if it's clear. Thank you. So that's how digital analog signals work. Here you can see this is an example of an analog signal. So in real life, this is when you're measuring anything, it's not going to be either high or low. It's going to keep varying, right? So this is how analog signals are recorded, and this is how they are processed. So that is it for analog and digital signals. Now I told you that analog is only input, but what if I want to send an output that is analog? What if instead of wanting my bulb to switch off and turn on, which is how we use digital signal, if we want to turn off the bulb, we'll use a low signal, and if we want to turn on the bulb, we'll use a high signal. But if we want the bulb to glow at half the intensity and you want to send only half the voltage, then how do you send that? So the question is, can we send out an analog signal? Not directly, but Arduino has the functionality of a pulse width modulation pin. Through these pins, we can get an analog output using digital pins. So when you have a pin that is set at low for a period of time, then the output you get will be 0 volts. And say I change, so I can now change it to high, then I'll get 5 volts. What if I keep alternating? What if I uh, make it high and make it low, and I do this at a very high frequency? Say I have a 50% duty cycle, that is the time for which it is switched on. So I keep it at high for half the time and low for half the time, and I do this at a very high frequency. Now, when I do this at a high frequency, instead of getting a 5 volt or 0 volt, I'll get an average value. I'll get 2.5 volts. Isn't that cool? So just by using 0 volt and 5 volt, I'm getting a value that's in between 0 and 5. And now I can do this for any value, right? So let's take a 25% duty cycle. Duty cycle is nothing but the time for which you have kept the signal at high, at 5 volt. So 25% means for 1/4 of the time, I have the signal at 5 volts, and for 3/4 of the time, it's at 0 volt. So 1/4, and now this we average it and we get 1/4 of 5 volts. We'll get 1.25 volts. So using the same process, we can get any value within 0 to 5. What do you guys think will be a 75% duty cycle? You can answer on the chat or you can unmute and answer. What is a 75% duty cycle? So what voltage will you get? You have the high signal for 3/4 of the time and low for 1/4. So what do you guys think we get will be the voltage? I have an answer here, 3.75. That is correct. Good job, guys. 3.75 is correct. So how do we get 3.75? It's 75% of 5 volt. So 3/4 of 5 volt. It's it's not 1/3, but the 3/4 of 5 volts, because we're having it at 5 volts for 3/4 of the time. So instead of, if you had it for 100% of the time, then you'll get constant 5. But if I reduce that to 3/4 and I make it low and I alternate again, so I'll get 3/4 of 5 volts, which is 3.75 volts. Let's try that again, shall we? What do you guys think will be a 30% duty cycle? So remember, 75% of 5 volts, I'm getting 3.75 volts. So what will 30% will duty cycle give me? That's wonderful. All of you guys got it right. It is 1.5 volts. Good job, guys. You understood analog pulse width modulation pins. That's amazing. So moving on, we have now seen what these pins are. Now, what do we connect to these pins? There are many electronic devices that are available. These are some of the basic things we'll use in our projects. So you have sensors which are used to record data in our environment and use them in our calculations. You have switches which work just like your switches at home. They break the circuit or close the circuit. You have a motor driver which is used to control the motor usually, LEDs which are light sources, and breadboards. Let's start off with breadboard. A breadboard, when we're making simple projects, we usually use breadboards. What this does is it makes our connections way easier. You might, more often than not, we will be connecting more than one device to the same pin. You say to the ground pin, every device that you have will be connected to the ground pin. but there are only two ground pins available on Arduino. We can't use only those two pins to connect everything. So that's where we have a breadboard. So how a breadboard works is you have all these pinholes and they're all connected in a particular fashion. The last two rows are connected all together and we usually use them for power and ground. So since all these pins are connected together, I can connect the power of Arduino to any one of these pins and any other device that I want to connect to power, I can connect from this point or any point along this line. Same for ground. So this you can imagine how confusing your circuits would be if you had to connect everything to the same point. But here we are making it way easier by enabling us to have a long set of pins that are connected to the same point. How this works is underneath all these pins, there will be metal strips. So under these pins, say there will be a metal strip. So once you connect anything to this point is also in electrical contact with that pin. So these are what we use for power and ground. For anything else, all these columns are connected together. So what I've highlighted in green, all these pins are connected together. So each of these columns numbered from 1 to 30, they are connected together. So say I want to connect an LED through a resistor to ground. So like as in this case, I can connect the LED and instead of directly connecting the resistor, which would be a little bit of a headache, we can connect it to a point on the same row as the LED terminal. So all these points are connected together and through LED, it is connected to this point, which is further connected to the wire and it forms a closed circuit. So this is how we'll be making connections in our projects. Any questions on breadboard? Okay, let's move on. So this is a very basic component that we'll use in our projects. Next, we have sensors. There are so many different kinds of sensors available. These are a handful of sensors. As you can tell, as the name suggests, this senses color, this senses the different gas. Ultrasonic sensor we use to measure distance. PIR, it's used to detect motion. We'll see a cool application of this in today's session. And a flex sensor measures how much it bends. And LDR is a light detecting resistor. And you have many other sensors. You can read about it and it'll keep going on and on. There's so many resistors suitable for each and everything you might want to record in the environment. Now, these are input devices. Moving on to output devices, we have motors. There are also different kinds
Niveda,
of motors. Yeah.
Niveda, one second. Kumar has asked you to explain the breadboard connection again.
Yeah, okay, I'll do that.
That example.
Yeah. So what they have tried to do over here is make a closed circuit involving an LED, a resistor, and a wire. So you want the LED to be connected to one end of the resistor, one terminal of the LED connected to one end of the resistor. So we saw that all these pins are connected together. So I can connect one terminal of LED to any one of these points and then connect the resistor to any of these points. That's what they have done here. One terminal of LED is connected to a point on the row and another point of the row is connected to a resistor. And we want to connect the wire to the other end of the resistor. So the other end of the resistor is at another point. Now this side and this side are isolated. They are not connected. So they are connected to another point on the other side and the wire is connected to the that row. So this end of the resistor is connected to this wire. So far we have gotten a continuous link between the LED, resistor and the wire. Now this wire is probably connected to a power source and then it's and the other end you want to connect to the LED. Again, they have made use of the fact that all these pins are connected, and they have used one hole for the wire and another hole for the LED terminal. So now this forms a closed circuit. Wire to LED on the same row, and through LED to another row, and through that row to the resistor, and through the resistor to a different row, and through that row to the connector, and a power supply, possibly. Is that clear?
It all it's clear.
Yeah. Okay, cool. Yeah, yeah. If you guys feel like I'm going too fast, please tell me. I can always slow down. You can use one side also. Yeah, so if you want to connect, you can connect the resistor to this point, say, and connect the wire to another point. That also you can do. You don't have to use both sides. Any more questions on Red Bull? Yeah, this and this are not connected. This is connected separately and this is connected separately. There is no positive or negative for the breadboard. It's just a bunch of metal strips. If by connecting any point to a power supply, you will make that as positive. To the power, positive of the power supply, you will make that as positive and negative. You got that? There is no specific terminal for the breadboard. It is labeled so just for better ease of connecting, but you can connect it other way and there would be no problem. You can connect negative to the plus indicated one and positive to the minus indicated. That would be no problem. It's just a metal strip going along that line. That depends on the breadboard. So too high a voltage and it might get short. So they do have a voltage limit, but for most applications, I think it's fine. Any other questions? Okay, so let's move on. If you guys have any more questions, even after I go ahead, you can tell me. I will answer them if I will definitely answer them. Okay. So we were seeing motors. So these are output devices. Using your Arduino, you can control how much you want it to turn at what speed you want it to turn. So a DC motor is a continuous running motor. It will go on continuously. A servo and stepper, you can control how much you want it to turn. Now we've made all the connections to our Arduino. How do we power the Arduino? Now in an Arduino, there are 5 ways in which you can attach it to connect it to a power supply. So we have a USB connector, a battery connector, a barrel jack connector, and further, two of these pins can also be used. Now all of these have their own specific connectors. So whichever connector you have available with you, you can use that to power your Arduino. And you can also use the VN pin to power your Arduino. 3.35 volt pin is not advisable because they have a very strict uh, tolerance. So if your voltage is too high, then that will damage your board. Finally, we have to program our Arduino. Now we've made all the connections and we've powered up our Arduino. Now we have to tell the Arduino what it must do, what we want it that we want it to collect in information from the sensors, we want it to process the information, and or we want it to send out the information to any of the output devices, an LED screen or a motor, a buzzer, anything. So for that we use C++. We also need a software to program the board. And Arduino provides a software called Arduino IDE. 3.3 volt, 5 volt are for power output, but they could be used as power input as well. It's not advisable though. So don't worry about it too much. So let's get started on the IDE, how it looks. So you can either use the online editor or download the desktop IDE. This link has the instructions for both the methods. Once you go to this website, you will see this window and you can download whichever, depending on your OS, you can download the right IDE. This website has the instructions. At the end of the session, I'll post all these links on the chat so you guys can look through it and download it for yourself. Now let's look at the different parts of an Arduino. I will share a different screen. So this is the screen of an Arduino. For an Arduino, we use C++. That is what is supported by Arduino. For if you want to run a program that uses Python, you can use, you don't have to install now. You can use other development boards like Raspberry Pi or Jetson Nano. So we'll look at the basic features. You guys can look through it right now and you can download later on if you're interested. So this is the editor. This is my editor, and this is where I'll put the code. And also this is where I'll be running my code. And on the panel on the left, we have Sketchbook, which is where all my programs will be saved. Then there's Boards Manager. So, I told you there are many boards available, right? So you can look up whichever board you want. Say I want an, say I'm, so yeah, so there are different kinds of boards, and whichever board you want, you can install that package. Like you would have come across libraries in programming languages, right? All of these are libraries that will be required to use that particular board. The same with the library manager. So this is for more specific applications. Say I want to run a servo motor. Now I have a package that I can install and then start using over here. And just as in any other library that we use in C, we'll include the package name and start using that package. Then we have debug. So once you have written your code, and your code may have errors. And debugging is the process of removing those errors. So this panel is useful for that. And this is just your usual search. So once you've written your code, you can verify your code. So what this does is it will compile your code and let you know if there are any errors in your code. So you can rectify all of those errors before you upload your program to your Arduino. And once you have, so the same with debug. So you can, once you write your code, you can debug and verify. And once you have verified your code, you can upload your code. So this is what we use to upload the code. And this is where you choose your board. Say I have an Arduino BT, I choose the board. And also once I've connected, ports will appear. So then I can choose whichever port I want and click OK. And I would have connected my Arduino to my system through cable, USB. You can connect it and then you can upload your code. So this is what you use your Arduino IDE for, to write your code, verify it, and upload it. That is the purpose of your IDE. There's also the serial monitor. So the data you receive from the Arduino can be printed over here. That is what we serial monitor. Now, we don't have ID. This is useful when you have a board at hand and you want to use that board. But not all of us will have an Arduino board just at our home, right? So for that, we will be using Tinkercad later on to simulate the board and the IDE, but in an online editor. Now let's get into the actual programming part. Before that, any other doubts? Uh, okay, let's move on. So let's get into the programming and look at some basic syntax. You would have seen on my screen there was a void setup and void loop. These are two functions. So the void setup is executed once. Once you have the code in your Arduino, you can, when running, if you run it, it'll be executed once. Now, this is where you can uh, put all your statements to set pin modes and also to begin the serial monitor. Each of the pins in your Arduino that you're using will have to be set as input or output. You have to tell the Arduino whether you want it to receive data through that pin or send data. This we declare within the setup function. Also, we will, if you want to print the data received from the Arduino, you will be printing that on the serial monitor, and you have to begin the serial monitor and give the rate at which you want data to be transferred. We'll see that over here. And now loop. The loop function is where your main code is. So anything you want it to do, you put it inside the loop function and it will be repeated indefinitely. It'll once the it runs the full code, it'll go back to the first statement and run it again. So this will keep on running till your Arduino is switched off. So anything to collect data, to receive input, to send output, and to process any of the data that you receive, all of that functionality you will be doing within the loop function. So these are the two basic functions that are always a part of any code, any Arduino code. Now within void setup, like I said, we'll mostly be using pin mode and serial.begin. The syntax for pin mode is you pin mode and within parentheses the pin number and input or output. Each pin in an Arduino is labeled. So the digital pins are labeled with numbers 1, 2, 3, 4, 5, 6, like that. They label through numbers. And analog pins are labeled as A0, A1, A2. So you give the pin number and then you tell whether you want it to receive data, input, or send data, output. So here's the example pin mode 12 output. So now I can connect to the pin number 12, I can connect any output device. So I can connect an LED to output. But now if I give input, instead of output, I'm giving pin mode 12 input. I cannot connect an LED. An LED is a An LED is a output device, so I cannot connect it to an input pin. But if I'm connecting it to a sensor or a button, then I will declare this as input. Serial.begin is just for your serial monitor, and usually we set the rate as 9600. Now these are functions we use within the loop function. So starting off with digital functions, so these we use with digital pins. All the pins that are numbered as 1, 2, 3, 4, we can use digital write or digital read. Digital write we use for output pins. So you're sending out information. So you're writing information onto that pin. So I will give digital write and the pin number, say 12, and I give high. Now my pin 12 will have a voltage of 5 volts. Instead, if I give digital write 12 low, my 12th pin will have 0 volts. So if I connect an LED to my 12th pin and I put digital write 12 high, then my LED will glow. If I put digital write 12 low, then my LED will stop glowing, will not glow. So this is what we use digital write for. It is used for digital pins and it sets the pin to high or low, 5 volts or 0 volts. Next is the input function. You want to read the information that you're getting. For that, you use digital read and the pin number. So whatever voltage the pin is at, it'll it'll be recorded. And you can store this information in any variable. Say we'll be using a button later, and I want to know if my button is being pressed or not. If my button is pressed, then that pin will be at high. So if I give digital read of that pin equal to button, when I press that button, the variable button will have value high or 1. That is the use of digital read. And it only takes high or low. So even if you have an analog value, that will be converted to low or high. Next, we have analog write and analog read. Analog write can be used with PWM pins. So an analog output we saw earlier can only be sent through a PWM pin. So whenever using analog write, make sure that your pin is a PWM pin. And then whichever value you want. So this value for an Arduino is between 0 and 255. 0 is always off and 255 is always on. 0 is low full time and 255 is high full time. 0 duty cycle and 100% duty cycle. If I want a 25% duty cycle, then I will give 1/4 of 255. Here I have given analog write of 6 127. 127 is nearly half of 255. So the sixth pin will be set as 127. What? Is something wrong?
I can continue.
Yeah, okay. So that's the function of an analog write to send an output of an analog value. And using the analog pins, you can read analog input. So the same way we use a digital read pin, we'll use an analog read pin, except with an analog pin. Now this also can be stored in a variable, and instead of returning just high or low, it will return a value between a set range. So this range depends on your converter. So an Arduino in any development board will have a analog to digital converter. So this converter will convert your analog value to a digital value that can be understood by your Arduino. So a 10-bit converter will have a range of 0 to 1023. So the value that you're sensor is giving will be calibrated to this range. So these are the most common functions that we use to write or read from a pin. And then we have a delay function. A delay is nothing but, as the name suggests, the next statement is delayed. So it stops all function for whatever time you're specifying. And this time is in milliseconds. So I give delay 2000, that's 2 seconds, 2000 milliseconds. Everything will be stopped for 2 seconds. So if I want my motor to run for 5 seconds and then stop for 5 seconds, I will give I will give digital write of high, the pin and high, and I'll give delay of 5000. Then I'll give digital write low, delay 5000. Now what it'll do is it'll set it for high, and the next statement is delay. So for the next 5 seconds, it'll be set at high. And then we're setting it back to low, and we're waiting 5 seconds. So that's how we um, control the time that we want anything to run for using a delay. And serial.print line is your print statement. It's your usual print statement to print on your serial monitor. So this will be, it'll just print, it's just a print statement, and ln is just so that the next statement is printed on the next line. If you don't give ln, it'll be printed right next to each other. For clarity, we usually use print ln. So,
Ask you to explain the read functions again.
okay. Say I have a sensor and I want to read the value of the sensor. The sensor will have some data that it's reading, right? I have a temperature sensor. It can detect the temperature, and I want to know what the temperature is. To know what the temperature is, I will use the read pin. So a temperature is not either 0 or 1. It's an analog value. So I will use an analog read pin. Analog read, and I'll give the pin number. So my sensor is sending data to the Arduino, and the Arduino will receive the data. And this data will be converted to this range. So say you have a sensor that can read from minus 40 degrees Celsius to 100 degrees Celsius. Data will, it'll send as some voltage value. The sensor will read the temperature and it will send a particular voltage value. This voltage value will be converted by the Arduino to this range. Was that clear? I hope that was clear. I will be doing a simulation on Tinkercad, so then I'll explain what I said with the motor. I might have gone a little too fast with that. I will explain that again, don't worry about that. Delay also we'll see. I think it'll be more clear when I am doing some examples with you guys. I'm not sure I understand the last doubt. Could you rephrase that maybe? Most of your doubts with this syntax will be cleared when we work on the program. Don't worry about that too much right now. So that is all the basic syntax that we will need. And now we're ready to build our first project. Like I said, we all don't have Arduino lying around at our home. So what we can do is use Tinkercad. Tinkercad is a very useful tool that we use to model and design our circuits before we actually implement them. Even if we do have an Arduino at hand, it's better to first design it on Tinkercad and simulate it so that there are no errors and then implement it on your Arduino. If you give too high a voltage, then your devices might get short. So all of these can be prevented if you first do it on Tinkercad. I hope all of you made an account and do open the screen so we you can follow along with me. No, no, delay is not the it's not like that. Yeah, it just stops the program. I hope all of you guys have Tinkercad. It'll be very useful if you guys do follow along. So for our first project, let's make an LED blink. One second. This is the screen you will see when you start any new circuit on Tinkercad. I hope you can see my screen. So the first component we need, of course, is our Arduino. So you can search up all your components on the right side panel. You'll have a panel with all components. So say you can see resistors, LEDs, you have transistor, motors, sensors, all of that you have. And there are more components here as well. For now, we'll take up our Arduino. You can search on this search panel over here. Let's also use a breadboard and see how we to go about using a breadboard. You can search up a breadboard, and this is what it looks like. So we have an Arduino and a breadboard. To connect any wire to any point, you can just click on any of the connecting points and drag. So this is your wire, and this is how we can connect between any points on our design. You can also change the color of your wire. This is useful when you want to have a more clarity between your connections. So the usual convention is to connect power with red. So I'm connecting this row to the 5-volt pin. It's on this side of the Arduino. You can see 5-volt over here. You can also see ground. We'll be connecting ground to the other row on the breadboard. So I've connected a point on the breadboard to ground. Power. Next, I will be connecting the ground. So I'm connecting this row to ground. When you start any design, this is the first thing you will be doing, connecting the power and ground. Next, let's take an LED. Here you can see the LED has two terminals, cathode and anode. Cathode is the negative terminal and anode is the positive terminal. In real life, you will observe that the anode is slightly longer. That's one of the ways in which you can differentiate between the two terminals in real life. Here also they have given it as slightly longer. So your anode is the positive terminal and cathode is the negative terminal. So I'll connect this to any part of the breadboard. Next, I want to connect the anode to the Arduino. So I can tell the LED when to glow. So I'll connect it to any of the digital pins. I'll connect it to 10. And the negative terminal I connect to ground. I'm not, as you can see, I'm not connected directly from terminal to Arduino. I've connected it through the breadboard. This is how we use a breadboard. So the other terminal, cathode, negative terminal, I'm connecting a connected point on the breadboard to ground. But an LED, this LED has a low current requirement. So if you run a high current, so we have a 5 volt, right? So if you run 5 volt through it, the current will be too high and your bulb may fuse. A Tinkercad will give you a warning. So we can use a resistor to reduce the current flowing through our LED. So I can connect it. I don't have to connect it along the no, same line. I can connect it to a different point. And from this point, I can connect to ground. Is the circuit clear? So this is our design. We're done with wiring our circuit. What we have done here first is connect power and ground to the board, and then we have connected the positive terminal anode to the Arduino, one of the digital pins of Arduino, and then we have connected the negative terminal to ground through a resistor. So now this is a complete circuit. Now we can move on to our code. When you click on code, this is what you'll get. You can click on this blocks and go to text, so you can code that in C. By default, it will give you the void setup and void loop functions. So the first thing we have to do is tell Arduino that I want to send data through pin number 10. So I'll give pin mode, the pin number, which is 10, output, because I'm sending out data. So it'll be output. Then within void loop, I will tell the Arduino to set it to high for a given amount of time and set it to low for a given amount of time. Let's make it glow for 3 seconds and not glow for 1 second. So let's make it glow. How do we set it? How do we make the LED glow? We use digital write, again pin number, high.
And Niveda,
Yeah.
actually, some people in the comments have told that like they didn't get the function properly, so they want to explain functions again whenever you said.
Okay.
And also, now most people are familiar with only Python, so they want you to explain C++ as well about the syntax of C++.
Okay, okay. So you want me to go over the syntax again? All of the syntax? So okay, well let's quickly run through the syntax again. In Python, you will specify functions as def, and then you will give your function name and tell it what to do, right? In C, in C, you have to specify the return type as well. In Python, it'll take it by you don't have to declare the type of data you're returning, but in C you have to type. So void tells that you're not returning any data. So there is no return command. So in C you will give the data type and then your function name and then curly brackets. Within your curly brackets, you will specify what the function has to do. So for Arduino, we use two functions mainly, setup and loop. So setup function will run once, while the loop function will keep running again and again. It's like your while loop. It'll keep running again and again till your Arduino switched off. It'll keep running. So these are the two functions that we'll be using. The user-defined functions, that is. We will be defining what these functions do. So the main thing that we use setup for is to tell Arduino which pin is input and which pin is output. So that can be done using pin mode. So this is, it's like your um it's just like your print function or anything. It's what it does is it tells Arduino this pin number is input and this pin number is output. So we put this statement within setup. So it runs once, right? So in the beginning itself, we'll tell Arduino this pin is input and this pin is output. Am I sharing the right screen? Am I sharing my presentation? Yeah, okay. So that is the purpose of this pin mode. Next, we have serial.begin. This is to start your serial monitor. Serial monitor is when you have any print statement, it will be printed in the serial monitor.
Vedha.
Yeah.
So Adaliki is asking how to open the code editor in Tinkercad.
On the top right panel, you will have, no, on the top ribbon, right? You have a lot of, can you see my Tinkercad page?
Yes, it's
Yes.
visible.
Okay. So you can see code over here. Click on that.
Okay.
Uh, when you click on that, you will first initially get the blocks. So you click on this thing. So it says change edit mode, right? You click on that and go to text. It'll ask all this. You can just click continue.
Okay.
Okay. So this is just to start our serial monitor. These are the only two things we will be using today within our setup function.
And whether your code got deleted because you
Yeah, it's
changed the
fine. It's
block.
fine. Yeah, it's fine. Next, this is what we use to collect data and send data. Digital write is to send data. We have digital pins and analog pins. Let's first focus on digital pins. To send out you can either send out a high or a low signal on your digital pin. So what you give is you give digital write, the pin number, and high or low. So this will set that pin to high or low, 0 volt or 5 volt in an Arduino. So when you want to send out output, you will use digital write. This is an output function. Next, for digital pins, the input function is digital read. You're getting data from your sensor, maybe what any input device. You want to read whether it is low or high. So this is your input function. So digital read and the pin number, whatever value the pin is receiving, either high or low, will be given by this. This you can store in any variable you want. Variable of type integer. Again, in C, you have to declare the type of variable that you're using. So we'll mostly use integer. The keyword for that is int, int. So you can give int, name of your variable is equal to digital read of pin number. This is for digital pins. Next, we have analog signals. The same way we use digital read, we can use analog read. And you can connect for an analog pin, which are labeled as A0, A1. You'll be able to see on your Arduino, on the opposite side to digital pins, there will be analog pins. So you can read input in those pins using this function. And if you want to send an output of analog value, then you will use analog write. This you will use with PWM pins. You'll give same way use digital write, you'll give analog write pin number, but instead of high or low, you can give any value between 0 and 255. 0 is equivalent to low and 255 is equivalent to high, and but you can give any value between 0 and 255. Is that clear? I hope that's clear. Then we have delay. Delay is nothing but pause. You're telling the program pause for this much time. Stop running for whatever time I'm giving. That is all delays. And this is just your regular print statement. And it gets printed on your serial monitor. Now we'll use these functions and we'll see how it goes. Can you see my Tinkercad screen? Okay, so I'll move on to the code. So we have finished wiring our circuit. Now this is the default that it gives you, and you can see pin mode within the setup function. So pin mode and our pin is pin number 10. So we'll give 10 and output because we wanted to send data. Then within the loop block, we'll tell it to glow and switch off alternatively. So for it to glow, I have to set it at high. High is on and low is off. So I want it to turn on, so I will give high. Now because this is a digital pin, I will give digital write. Write because I'm telling it, so I'm writing the value. And then pin number, which is 10, and high. In C, you have to give a semicolon after each of your statements. Uh, then, now I want it to glow for 3 seconds.
Veda,
So,
Joshua is
yeah.
asking, why is the red wire from 5 volt What is the red wire from 5 volt connected to? I don't see it connected to anywhere.
Yeah, it is not required for this, but usually you will see later on if I want to connect another device, then I want to connect it to power, then I can directly connect it to it. Here it is not required. I just connected it to show that yeah, this is how we usually connect the breadboard and the Arduino power and ground. Here it is not connected to anything. That you're right. You guys can unmute and ask your questions because I wouldn't be able to read the chat all the time. So we have set the LED to high. Now if I run the code, how do we run the code? We click on start simulation. Right next to code, there's start simulation. So when I click on start simulation, my code will run. If there are any errors, it'll let me know. If there are no errors, it'll start running. So I have set it to high and it keeps looping. So it will continuously glow. I hope that's clear. So since I've set it to high, it will glow. Now I want it to glow for 3 seconds before I turn it off. So to turn it off, I will give digital right pin number and low. This statement will turn it off. But before it turns off, I want it to glow for 3 seconds. So I'll tell the Arduino that delay for 3000 milliseconds. So it'll start glowing. Then I have stopped the next statement. So it does not switch off for 3 seconds. Delay does nothing but pause. So after this statement, the program will pause and my LED will glow for 3 seconds. Then it will turn off because I'm turning it off in this statement. And I want it to remain turned off for 1 second. So that's 1000 milliseconds. And that's the end of my function. So now it'll go back to this. So what it does is it turns on, then pause for 3 seconds. So it keeps glowing for 3 seconds. Turn off, pause for 1 second. So it remains off, turned off for 1 second. Then it goes back to this statement. Turn on, 3 seconds, turn off, 1 second. And this keeps running in a loop till I turn it off. Is that clear? So I will run the code now. You will see that it's glowing and it's glowing for 3 seconds and turned off for 1 second and then again starts glowing 3 seconds and turns off for 1 second. So this is our basic blinker code. Is that clear? Do you guys have any doubts? Yeah, our LED is on during the delay time. Is my screen lagging? I'll share my window again. 1 second. Yeah, and it turns off during the next delay. If we don't write three delay of 3000, it'll run at the speed at which this code runs. So the code runs at a very high speed. So the voltage will keep fluctuating at a very high speed. So it wouldn't give any proper output. If this is clear, we can move on to another circuit.
Yeah, Adilike, do you want to ask something?
Do I want to ask
Yes,
something?
yes, raise this hand.
Oh, yeah, yeah. Do you have anything you want to?
So he says his circuit is not working properly. Okay, you send the picture in the chat and I'll look into it. You can
Yeah.
continue.
So let's try something a little bit harder. In your dashboard, you can click on create circuits, and that will give you a new canvas to start with. Same routine. Arduino, breadboard. This time we'll use the power and ground. So let's try to operate a motor using a button. So when we press the button, our motor must run. That is our goal. So we have a DC motor over here. And it has two terminals. This is the positive red terminal and negative terminal. As usual, we connect the negative terminal to ground and the positive terminal we'll connect to one of the digital pins. I'll connect it to 3. If you connect it the other way around, say this to your pin and this to ground, then your motor will run in the opposite direction. When you're running your code, it'll tell you the RPM. And when you connect it the other way around, it'll give you a negative RPM. So this is only for the directions. The way you connect it determines the direction. And a button. This is a push button. It's a two-sided switch. So you can use either the B side or the A side. We will use the A side. 1A, connect that to power. And 2A, it has to be connected to 2 points. This one terminal, we need it to be connected to 2 points. We'll connect it to 6 and through a resistor. Now take a resistor and connect that to ground. So the push button is connected to has 3 connections. 1A is connected to power, baseline. 2A is connected to Arduino, one of the pins in Arduino, digital pins, and to ground through a resistor. Same thing we did with LED, we're adding a resistor and we're connecting that resistor, one end of the resistor to the push button and the other end of the resistor to ground. So let's look at this again. Arduino is connected to power and ground, motor to ground and Arduino pin, and the push button to power one of the pins and ground through a resistor.
And even the Lakshmi Kirtanas has how we know uh, that to connect to the particular digital pin. He has
You
to
can
which
connect it, yeah. Okay, with to which one? Right? To which pin? Okay. No, you can connect it to any of the pins. Any pin. If you want, so they're just numbers. You can connect it to any of these 13 pins, 14 pins, including 0. But if you want a pulse width modulation pin, you have to connect it to one of these pins marked with a tilde. Otherwise, you can connect it to any of these pins. Similarly, on the other side, we have analog pins. So if you want to read an analog input, you can connect it to any of these pins. In your code, you will have to specify that which pin you're connecting to. That's all. All these pins are equivalent. So now let's try to program this circuit to start running when I push the button. Again, code, change blocks to text. And we can start writing our program. Earlier in our previous code, every time we wanted to refer to the pin, we put that pin number, right? Instead of specifying the pin number each time, we can declare a variable. I will call a variable, I'll declare a variable of type integer. The keyword int tells that it's an integer. I will call it motor and I'll give the value 3. This is useful. Now you asked which pin to connect it to. So now in case I connect it to 4, instead of changing everywhere 3 to 4, I can use motor everywhere and change here alone. I can change it to 4. Same thing I will do with the button. And again, pin mode, motor. What do you guys think it should be, input or output for motor? And button. Tell both.
Input for button, output for motor.
Correct. For motor, you're sending out information. Your Arduino is sending out information to the motor. So it is output. And for the button, you're receiving information. The button is sending information to Arduino. So input. That is all. We have specified our pins as input and output. Now we want to read if the button is being pressed or not. For that, we will use the function digital read and we will save this in another variable. I will call that button state and it's again of type integer. Button state, it's equal to digital read of button. So instead of putting the pin number itself directly as 6, I have given button because I've already declared it as 6. What this does is it stores the value sent by the button in button state. So if I press the button, then it will be high, and if I don't press it, it will be low. I hope that's clear. So we want it to run when it is high, when I'm pressing the button. So when it is high. So this is your classic conditional statement. In C, you give it, it's again if, and your condition, you give it within parenthesis. So button state equal to high. And your code block, again, you'll give within curly brackets. So I want the motor to run. So I'll give digital write. I want it to turn on. So to turn it on, I will give digital write motor high and close the curly brackets. So this is my if statement. If my condition within parenthesis button state equal to high, then this is what it must do. So that I have given within curly brackets. Digital write motor high. So I'm turning on the motor. Else digital write. I want to turn it off. So what should I give over here? High or low?
Low.
Yeah, we give low. So now this will turn it off. You can close it. So I think that's it. We'll check if it runs. So you can see over here 0 RPM. This tells you the speed of the motor. So it's at 0 because it's not running. Now if I press the button, you can see that it has gone to 5,000 something RPM. So it's running. When I let go of the button, again 0. And when I press it, it runs. So I code works. So this is how you can make a motor run using a button. Is that clear? Any questions?
Ma'am, can you explain the circuit around that button?
Yeah. So this button is a double-sided switch. So we're using one side alone. So we're connecting terminal 1A to power and 2A, we have two connections from that terminal. One is to the ground through a resistor. It's it's and another connection to the pin. So the information when I press the button, the information gets sent to the Arduino through this wire. All these connections can be easily found on the net. So each button, each device might have their own set of rules on how to be connected. They can be fairly easily found on Arduino documentation, or there are sites that give step-by-step instruction on how to connect them and use them. I will send you guys the references. You can look through the various different devices and how they're to be connected. I hope that's clear. Is there any other question? The yes, code. So this is how you can run a motor. Now let's try printing something. Say I want to know if I'm pressing my button or not. It's not very clear when I press it with my mouse. You can't really tell if I'm pressing it or not. Say I want to print the button state. Now my serial monitor is over here, and this is where it will get printed. To print, firstly, I must start the serial monitor. So I am giving serial.begin. This is 9600 is the speed at which data is sent. And I will give and I'll give a small delay. No, I'll give a 1 second delay. So it gets, so I'm checking every 1 second whether I'm pressing or not. So I've start the serial monitor in within setup, and within the loop, I am printing button state. And for every 1 second. So I will press and then it'll print and then it'll wait 1 second and then it'll start again. You can see it giving 0 because I'm not pressing it. Now when I press it, it'll give 1. So 0 is equivalent to low and 1 is equivalent to high. So when I stop pressing it again, it goes back to 0. So this is how you can print any data that you want to see. And it's not just values, you can also print text. Yeah, you can print any text that you want. Say let me put in a different line. Spelling error. So it'll give me state 0. Because I haven't given ln, it prints on the same line. When I'm pressing it, it prints as 1, and when I stop pressing it, it goes back to 0. Let's try one last thing. Let's try to run this motor at half the speed. Let's use an analog pin, analog output. Firstly, to send a analog output, make sure that this is connected to a PWM pin. So you can click on the wire and move any of its joints. So I'll connect it to 5. Now this is where you can see the advantage of declaring these. If I had to, if I did not do that, now everywhere I had put 4, I will have to change 5. Here I'll have to change. Here I'll have to change. Again, here I'll have to change. Now instead of doing all that, I can simply change over here. Done. So now I wanted to run at half the speed. So instead of digital write, I will give analog write. Again, the pin, which I've called motor. And for analog output, it goes from 0 to 255. 0 is low and 255 is high. And it increases linearly. So if you want half, I should take half of 255, which is nearly 127. So I've given analog right, motor, and instead of high or low, I've given a value. This value will tell my motor how fast. It's from, again, I'm repeating, it's from 0 to 255, and I want half the speed, so I'm giving 127. Now you can see the RPM. It's earlier it was 5,500 something, right? Now it's nearly half of that, 2,700. Half of that. So this is how you can control the speed of the motor as well. Any questions? Do any of you have any more questions? Okay, the speed. Speed. So when I gave just high and low, low was off and high was on. So 0 volt, 5 volt. And 5 volt is the maximum. So it runs at maximum speed. When I give digital write high, it runs at maximum speed. And the maximum speed for this motor, which you would have seen earlier, is 5,500. That is the maximum. So when I give high, it gives you the maximum value, which is here 5,000. Now, instead of running it at full speed, I want to run it at half the speed. So I want to give half the voltage. So to specify the voltage or specify how much you want, here the analog value ranges from 0 to 255. 255 is high, full speed, and 0 is turned off. So depending on what speed I want, I can give any value between 0 and 255. So if I want half the speed, I will give half of 255, which is 127. If I want 1/4 of the speed, I can give 1/4 of 255. So instead of digital write, I'm giving analog write. Now digital write is only on or off. Analog write is on, off, and everything in between. So I want something in between. So I'm giving analog write. Say if I give 0, which is essentially low. I forgot semicolon. Which is low. So even if I press the button, it doesn't run because analog right in 0 is off. Now if I wanted to run at full speed, I'll give 255, which is the maximum. 255 is equivalent to high. So 0 is low, 255 is high. So now if I press the button, it runs at full speed. Now let me change it and let me give some low value. Let me give 50. What you expect? You expect a value which is less than 1/4. So when I press, you get 1,000. So you can see that it has reduced the speed over there when I'm pressing the button. You can see that it's lower, less than 1/4 because I've given 50. Say I want more than half. Let's say I put 200. Then you have a speed that's lower than the maximum speed, but higher than half the speed because I've given 200. So the speed from 0 to 5,500 is linearly dependent on the range 0 to 255. I hope that's clear.
I just asking you to show the circuit.
Yeah, okay.
Urko is asking why is the resistor there?
Okay, so for this button to function, this is called a pull-up resistor. Uh, it needs to. So I've connected it to power on one side, right? It has to be grounded on the other side. But then you also need it to send signal. So this is how you connect this button. This it's just specific to this button. Anything else? You can ask anything from earlier also. We have about 10 minutes left. If
Are
you
you looking at
guys,
the chat?
huh?
Are you looking into the
Um,
chat?
no, if when I look at the chat, can you still see my screen?
Yeah.
Oh, okay, cool. Cool. Uh, oh, thank you for attending the session. If you guys want, I can show you one more thing. Or if you want a particular constant RPM. Here it is fluctuating. Mm, for a DC motor, I think you will still get slight fluctuations because um you're not directly giving 2.5 volts or anything, right? It is an averaged value. Using a motor driver, maybe you could get a constant RPM. Analog in pins, no, we haven't used them. Where you do use them is if you're using a sensor and you want to read the value of that sensor. I can show you another example right now where we can use analog pins. So if you want to read the value of the sensor, then you can connect it to the analog in pins. We can use digital, right, if you use a PWM pin. All PWM pins are digital pins, but not all digital pins can be used to send analog signal.
So those who don't have doubts can leave now, right?
Mm, yeah, I guess. Yeah.
Yeah, guys. So attendance is
Thank you.
done. So if you have any doubts, feel free to ask, or else you can leave. Or if you want
I will.
to see what the doubts of others, also you can stay.
Yeah, you can stay back, and I will go through something if it wasn't clear, and I will share the PPT. There's a very cool video over there where they use just using an Arduino. They do some really cool stuff, and there are some other examples as well in the PPT. You can look through that.
So one person wants you to repeat the button connection. Yes, what will happen if you remove the resistor connection?
It won't do what it's supposed to do. That's a simple way of putting it. It's um see if I remove the connections, say I don't have the resistor, then when I press it, it's not running properly, you see. It's giving me, I haven't even pressed it and it's still running. That's not what I want. So it's called a pull up resistor and it does regulate the voltage and it's required for the proper functioning of that button.
Yeah, that's it. So like when you don't press the button, the circuit remains unconnected, disconnected. So we don't have a particular low value or high value, so it'll be somewhere in between. So if you connect it to ground, it'll be pulled down to ground. So you'll get a zero input. So that's why it's called pull down resistor. And yeah, I think it's clear, right?
It's not about constant power. It's you can change the power, change the signal that your pin is giving. What your PWM pin does is using just low signal and high signal, it gives you an intermediate value.
So Pavanas has so button and motor are connected.
They're connected through the Arduino. So my button is connected to the Arduino and my motor is connected to the Arduino. So I'm receiving input from the button and I'm sending output to the motor. Um, Using on Tinkercad, I am not sure if there are audio. There is a buzzer that you can use, which is an audio output device. Any other kind of audio, it's not available on Tinkercad, I believe. In an Arduino, I think you can use it if it's compatible.
So and also a mini task will be posted after this session. So make sure you attend that.
Yeah, you will learn a lot more by doing the task.
So here Mohan has asked, can we connect media playing device?
No,
So,
okay.
what kind
So
of
you,
media are you expecting?
yeah, that also, and you cannot connect to the digital or analog pins. You cannot send out the required data you need for any audio or video media.
But you can use OLED displays and other displays, which we'll be exploring in the next session. So you have to wait till then.
Thank you guys for attending. Hope you guys had fun and learned a lot. If you do have any further questions, you can always put it on the group, or all resources we will upload on in files in Teams.
So any more doubts, guys? Yeah, if you don't have doubts, you can leave.
Feel free to contact us later if you have doubts on the mini task or anything else in general. It's 4. I think we can end the session now. Bye, guys. Hoping to see you in the next electronic session and every session after that as well. I had a lot of fun teaching you guys as well. Yeah.
Okay, fine. We're ending the session right now. So thanks for attending. See you on Monday.
Yep.